My name's Mike Vaughn. I'm from Lincoln, Nebraska, and what we're going to talk about today is rebuilding some coils. I've been doing Model Ts most of my life. I kind of grew up with them. My dad had Model Ts when I was a kid. I got photographs of myself in a Model T when I was 2 years old. And so I've been around them most of my life, and really got serious with Model Ts, about 15 years ago, and bought one and started restoring it myself. And the joy of the Model T for me is working on them. I really enjoy being able to repair and get the Model T back out on the road. So that's kind of where I'm going with this. I'd like to show you how I rebuild coils. It's not the rule on how to rebuild a coil, but it certainly gets the job done, and will make your car run really smooth if you've got a good operating coil system. So that's what we're going to talk about today. We're going to demonstrate a few techniques on how to adjust them up, how to replace a capacitor, and how you can make them work in your car so that you have a good running Model T. All right, what we need to look for in coils. We go to a swap meet and you want to look for Model T coils to rebuild. Generally, you can find pretty decent cores. There's a lot of different coils out there. You can buy brand new coils. I prefer the original Ford coils over all the rest. There's plenty of them out there. You're not going to run short on them. If you think about the numbers that were made, Ford built 15 million Model Ts. Multiply that times 4, just what was sold with the cars, gives you about 60 million coils that came with the cars. So the Ford coils are available. We have a good selection of them, and I like to go that direction. There's some other manufacturers out there. You can buy from the suppliers a plastic cased coil made by, I believe, a company that's called KW. And there was a KW coil that was built earlier in the 50s and 60s that manufactured a wood box coil, and the KW coil is a good coil. It's assembled a little differently than the Ford coil. The anatomy of it's just a little bit different in the way it's wired, and so for our purposes today, I'm going to talk about Ford coils and the anatomy of the Ford coil and the repair of the Ford coil. Even though a lot of this information will be very similar to what you could use on a KW coil, and once you got into a KW coil, if you've ever done a Ford coil, you'd understand that it's a little different but the same. If that makes any sense, you'll be able to get into it and understand how to rebuild it. So we talk about the differences. The coils that we're talking about today were made basically from late 1913 until 1927. However, there are a couple of differences with the early ones. The first late 1913, 1914 coils came with a brass top, like this coil here. The earliest ones had, like this one, 6 screws holding the brass top on. A little later they made a change and it's only held on with 4 screws. And there is a difference in the coil box on the early cars, on the 14 model cars, that doesn't allow the early coils to be used in a later coil box. So a lot of guys kind of like to have that pretty looking coil. Hey, gosh, it's a pretty coil. I think I want to put it in my 1925 Roadster. But then your lid on your coil box won't seat properly with that coil in there. So it's kind of a moot point. So for all practical purposes today, we're going to talk about the non-brass top coils, even though the function of the earlier coils is exactly the same. They're built exactly the same way as the later Ford coils. So we'll put those off to the side, and we'll talk a little bit about what to look for in a regular Ford coil. You go to the swap meet. There's a couple of ways you can do things. An inexpensive way or a little bit more expensive way, but either way doesn't cost very much money. The way I've done it for years and years is just to go over to like Harbor Freight and buy you a cheap digital multimeter. And you can't do a lot of testing on a coil with a digital meter, but you can test for resistance through your secondary windings to find a coil that's rebuildable. Now we're going to a swap meet, and we want to pick up a few Model T coils to rebuild. First of all, I want to tell you that if you think you need 4 new coils to build a set, buy 6 or 8, because even after we get them rebuilt, there can be a problem with one. And so it's nice to have a couple of extras that you can use as you're getting set up to use to put new coils in your car. And so I recommend that you do a couple of sets at a time. So find 8 coils or 6 coils at least and rebuild them. With this multimeter, this cheap multimeter that you can pick up at Harbor Freight for just little to nothing, we're going to test for some continuity through the secondary windings, and that's really the most important part of these coils, is to make sure that they have good secondary windings. If the secondary winding has an open in it, it's not a rebuildable coil. So we do want to make sure that we have a coil that can be rebuilt and has a good secondary winding. And it's simple to do. I set this up to read 20,000 ohms. We'll do a little conversion in there mathematically from the decimals, as all we're going to do is move the decimals over. And we read that this has 3.20, and if we convert that to thousands, it's going to be 3,200 ohms of resistance that we have going through the secondary in this coil. We're looking for 3,250 ohms plus or minus about 15%. So this is a good rebuildable coil. We'll be able to use it with no problems. You just move on to the next one and you can test it and do the same thing. Now this happens to be a KW coil, and the KW coils, like I mentioned a little earlier, have a little bit different construction to them. Their capacitors have a little less value to them, and we can see that this one has 2,110 ohms of resistance through the secondary windings, and that's okay for a KW coil. But there is a difference between them, and I just wanted to point that out on the KWs. All right, we'll test another one here. And we find that nothing happens with this coil. That means that the secondary winding is open. There's a fine wire in there. The secondary windings are wound with extremely fine horsehair wire, and they're easily burnt or broken if somebody's gone in there and hit it with a screwdriver. And if that's happened, the coil is non-rebuildable. There is another product that is being sold by some of our vendors. This comes from Fun Projects. John Reagan in Illinois makes these, and it's just a little tester that beeps, lets you know that you have a coil that's rebuildable. It does basically the same thing we did with the multimeter. It is set up to work on a particular range of resistance. So if it has too little or too much, it will not beep. But it's a handy little tool. It makes it pretty easy. They cost between $25 to $30. And you can stick this in your pocket, and when you're at a swap meet and you find a coil that you think you might want to buy, you can just put this on the secondary post, and that tells you that it's a coil that you could rebuild. It's pretty. All right, the next step that we do in our coil rebuilding is we're going to take a look at the anatomy of the coil, so that when we open one of the coil boxes up, we kind of know where parts are going to be. It gives us an opportunity to know what's happening before we do it and not damage something that would make the coil unserviceable. Okay, we want to talk a little bit about the anatomy of the Model T coil. If you lay the coil on the workbench with the bottom and at the bottom would be where the bottom contact is, facing towards you, and the point's away from you. And you'll find a door that you can open, and inside the door everything's going to be potted in tar. But if you know how the coil is put together, then you know what you're going to go for, or what you're going to be taking out to repair the coil. So we'll take a look at the interior of the coil, and starting like I said, with the bottom towards you on your left side, the first thing you're going to find is a condenser, and that condenser is wired to the primary core at the bottom. Also comes from your ground contact, and then at the top it runs to the bottom sets of points. From the bottom sets of points, then it runs on over to your C contact, which would be the contact that comes from the timer. Then going from the condenser, working inward towards the coil, generally you'll find a glass insulator. Sometimes they're made of wood, but most often they're made out of glass. And then inward from there, you'll usually find a couple of wooden blocks that separate the glass condenser and the secondary windings. Then you'll find your primary winding and your two secondary windings around the core, and then some wiring. But you can see how the wiring runs from the condenser. For our purposes today, we're going to talk mostly about where the condenser is located and how it's wired in there, because the condenser is the item that we're going to be replacing in order to rebuild the coil. And as you can see, the condenser is wired in there. Basically, you'll see one wire coming out of the bottom of the condenser, one wire out of the top of the condenser, and then you have a wire that's running from the top point connection down to the bottom of the condenser as well. So there's basically three wires that we'll be looking at when we take the condenser apart. The three wires would be the wire that comes from the bottom point contact, the wire that comes from the top point contact to the bottom of the condenser, and then the one that comes from the primary core to the condenser. And those wires are helpful in also removing the condenser if you know where they're located. I always start at the bottom of the coil when I start to remove the tar and find those two wires at the bottom, and that will help you. It actually helps in removing the tar a little bit if you know where those are at. So that's the basic breakdown of the coil. And coils, and we've selected the ones that we're going to rebuild. We get them back to our shop, and we want to do a couple of other tests. Now, I've got an analog multimeter on the table here, and you need to use an analog multimeter for a couple of reasons. I use the analog so that I can test the capacitor function in the coils, and it has to be done with an analog meter. A digital meter won't correctly read that. So if you're using a hand crank coil tester, you need to have an analog meter to be able to test the coil. Even after you put in a new capacitor, you want to be able to test it, you need the analog meter. So we're going to show a couple of tests that we can do while we've got the multimeter out, just to make sure that we have good connections in all three of the places. Well, actually there's 5 places that wires are connected within the coil. As we see in our diagram here, we want to be able to take our multimeter and take a look at what those connections are doing. So the first, make sure we have continuity on our contacts on this coil, and we're going to test from I've got them lettered here, E to A. E is the lower points, A is the ground to the timer, and B is the contact post that goes for your spark plug, and bottom over here is ground. We're going to test to make sure we have good solid connections on all of those. I've got my multimeter set to read ×1 on continuity, and so our first thing we'll do is we'll check from E to A, and we have good continuity there. And we'll check for from E to B through the secondaries, and we have good continuity through there. So we know that we're not going to have to do any repair on those wires. The next thing we're going to do, and we got to do it with the points closed, or with the points open, is we'll just stick a piece of paper between the upper and lower point here so that it can't make contact, and we're going to test through our capacitor. In order to do that on this multimeter, I'm going to have to set it up so that we can read the 3250 ohms of resistance through there, but we want to be able to also make sure that we've got a coil function. We already know we've got the resistance, but we want to be able to do coil function on here, and or condenser function, to make sure that it charges and then releases. I'm going to set my multimeter on 10K to read 10K so that we can test our capacitor function. Now, most Ford capacitors, these 90 to 100-year-old capacitors, have lost their ability to function properly. And when we test, we're going to test from A here to C on the bottom. And what should happen is our meter should jump up here to read about 0.50, somewhere in there, 0.47 microfarad, and then it should return to infinity. If it doesn't return to infinity, that's an indication that our capacitor is leaking. And so most of the time these Ford coils, that's the case. Our capacitors will be leaking. So we make contact here and we can see that it jumps up and it returns somewhat, but it doesn't return to infinity. So we definitely have a leaky capacitor. I want to demonstrate a coil that has a new capacitor in it to show you what the capacitor does on the analog multimeter. We're going to do that same test we just did on the other one that showed leakage, and we're going to run our contacts on our multimeter, and you'll see that the capacitor will charge and then discharge, but it's not going to show any leakage. It'll return to infinity. It bounced up. If you want to retest that, you have to switch polarity with your contacts and do it again, and it'll bounce up and return to infinity. You can test that all day like that. So that shows a properly functioning capacitor that's charging and discharging. I want to show this reference sheet. This is something that another sheet that I got from Ron Patterson, and this has some really good information on it, on your coil, and being able to find out, do a little troubleshooting on a coil. It gives some reasons over here that we have problems with the condenser open. You get a heavy blue arc on your points. So with an open condenser, you still get spark, but you get this heavy blue arc on the points. That shows a condenser problem. Also, if a condenser is shorted, there's no arc on the points at all, no spark. You can have a shorted condenser, and you get irregular current draw through the points as well. Secondary coil shorted, the points vibrate and it doesn't create any spark. That can be a problem that's not repairable. So it shows that as being a problem on here. And also your primary coil has an open in it. Again, something that I wouldn't worry about repairing. It also shows some of the values that we use to test the coil over here, and it shows the test that we just, and how to set up your multimeter to do the different tests that we just did. And we showed that over here, Ron says 3,300 ohms of resistance through your secondary windings, C to D. That's the first thing you want to look at when selecting a coil. And then the other values that we did just to make sure that we had good connections in the coil. All right, I just wanted to show a few of the tools that I have out that we use to rebuild the coils, and most shops should have about everything that I've got here. A couple of specialty tools. This particular tool here is used to adjust the spring tension on the points. That's something that you can buy from the vendors, Fun Projects or Lang's. Probably most of them will sell that particular tool. It's not very expensive, but it is a useful tool. A feeler gauge. This is just an old screwdriver that I use to dig the tar out of the coils with. It's the only thing it gets used for. So I use that particular screwdriver, some needle nose pliers and some side cutters. Use a putty knife. I use a small screwdriver, a very fine tip screwdriver, to help me get the coil cover off. And this particular tool is a tool that is kind of a custom made tool for setting the rivet on the top of the points. This tool has to do with setting the point gap on the cushion spring, but we'll show you a couple of ways to do that. You don't have to use this tool to do that. It just is a tool that I use to make it a little easier. Got a little bar of soft steel here that I can use to adjust that same thing with here, in a hammer, a ball peen hammer. So basic tools that we use to rebuild coils. All right, we're going to start our rebuild on our coils now. And one of the first things I like to do when I start to rebuild coils, and I might even start the day before I want to do this, is I would take my coils, and I like to spray a little penetrating oil on these bolts and nuts on our hardware on the top of the coils to maybe start to loosen them up. A lot of times these coils have sat around for many years, sometimes not very well protected, and we can get a lot of corrosion on these bolts and nuts and make them very difficult to get off. I will say that most of the time, if you soak them with your favorite penetrating oil a little bit, just spray it on there and let it soak overnight, you don't have too much trouble getting them off. But once in a while you'll find one that can be pretty difficult. And you just don't want to start twisting a wrench on these bolts, because you do have some wire contacts that are soldered to the other side of the bolt on the inside of the coil. And if you start twisting those around and around, you're going to break that contact. It can be repaired. It's not a big worry, but it's just something you don't want to have to do if you don't have to. So one of the things that I do, and this is just a little point, if you find one that you're having trouble getting the nuts off of, after you've cleaned them up on a wire wheel a little bit, and we'll demonstrate that, but if you still have a little trouble, you can take a hacksaw blade and cut a notch in here. Take a screwdriver then and put it into the notch that you've just cut, and then hold that bolt and turn the nut with a 5/16 wrench and to get it loosened up, and that works pretty well. I've had a lot of success doing that with them. So what we're going to do now is we'll take this over to the wire wheel. We're going to clean it up a little bit, and then we'll remove the point hardware. Okay, we've got our coil over here, and we're at the wire wheel, and we're just going to turn the wheel on, and we're just going to clean up the rust and some of the grime that's on top of these bolts and nuts. Polish them up just a little bit. Okay, now we're going to, after we've cleaned up our hardware on top a little bit, we're going to take and remove the old points and the old hardware from on top of the coil. We find a lot of times we have a lot of different things going on here. I don't know what all's in this one. It's got parts I've never seen before, but that's okay. Okay, Now we removed all the hardware from the top of the coil, and originally Ford had painted the tops of these with some black paint, and so you can still see traces of black paint on this coil. I don't replace the black paint when I redo the coils. We'll clean them up a little bit, we'll run some sandpaper around here, and I'm just going to put some boiled linseed oil on the wood just to preserve the wood. The reason I don't use the black paint is, and you can probably buy a black paint that doesn't have carbon in it, but I'm afraid that by putting black paint on the coil, I could cause a short with the carbon that's in the black paint, so I don't use black paint on them. I'm going to clean this up a little bit more. Our core, this wrapped with our windings here, is always a little dirty. It's got grease and oil from 90 years of sitting around. I like to take that over to the wire wheel and just clean that a little bit. I don't put a lot of pressure on it. I don't want to get into the insulation that's around the edge of that coil. Just cleaning the surface is all I want to do. And making sure that the little wires that are in that core are all straight. Sometimes you have to take a pair of needle nose pliers and bend those back up so that they're straight. But you don't need to do much more than that to that coil at that point. And we're going to lightly clean up our primary post here. Just keep in contact with the top. I don't want to break that insulation on the sides at all. And just polish that up a little bit. Maybe clean up our contacts a little bit more on these bolts. But now we have a good electrical mating contact on all of our hardware that remains on the coil box. All right. Now that I've got all my hardware off, we've got our old points here. They're not reusable, so I just, as you can take a look at these, they're pretty toasty anyway. We're gonna replace those, but I want to reuse my old hardware here, and just saves a little bit of cash on rebuilding them, and there's no reason why we can't recycle some of these things. When I clean these things up before I take them to the wire wheel, is I take a piece of safety wire, about 6 or 8 inches, and I thread all of our hardware onto the safety wire. Okay, after I've removed the points from the coil, I like to reuse the hardware that's on there. You can buy new hardware, but most of the time you'll find that the nuts and the spring and everything is still in pretty good shape. So I just like to clean them up a little bit and just lightly, and you can see as it's spinning against the wire wheel, I just light pressure on there, and it allows those nuts to actually spin on the wire wheel, and it just polishes them up. Okay, we've removed all of our hardware, and I want to clean up this box a little bit. This is, a little bit rough looking. It's been sitting out. It's actually probably been outside for a while. Got some wear to it. There's some issues in the wood. We've got a few little cracks. That's not a big deal, but we do want to clean it up a little bit. We want to be able to preserve this so it lasts another 100 years. So I just take some 100 grit sandpaper, and I just do a light sanding on it. I don't want to take a bunch of material off of these. I just basically want to clean them up. But again, just a light sanding. The reason I don't want to take too much off is these are a specific size to fit in the coil box, and if you start making them too thin, they're going to rattle around and you won't have good electrical contact with your coil inside the coil box. So we just And then up here on the top, I do the best you can, just getting around stuff here. It doesn't have to be perfect on it, but I like to clean it up as good as I can. All right, now we've got a fairly clean old coil box that we've got that'll really, when we put some Boyle linseed on it, look pretty much like a new coil box again.
Tootsie, goodbye. Tootsie, don't cry. The choo-choo train that takes me away from you. No words can tell how sad it makes me. Kiss me, Tootsie, and